won the race. I'll run that again. So you've got 5 objects to look at. Which object is winning? Right, the solid ice cube. That last one is an ice cube. Why is the ice cube winning the race? Well, I'm assuming that there's no friction anywhere. I think it doesn't say frictionless, does it? I think. But what is the ice cube not doing? Right, it's not rotating. So if it's not rotating, then it's got no angular velocity. If it's got no angular velocity, then we can forget this term, which means v squared will be even greater. So the object that doesn't roll will be able to go faster. So of course if you can go faster, you're going to win the race. So the ice cube doesn't rotate, it doesn't have any rotational kinetic energy. We could just ignore that term. So the v will end up being greater for the ice cube. I'm assuming no friction for all of them. So the ice cube will win the race because it's not turning some of that energy into rotational energy. And at the other end, the object that has the greatest moment of inertia is the hoop, because it has the largest moment of inertia. We looked that up on the previous page. So the hoop is going to lose the race. I think you'll find who finishes second. Which one? Is it this one in the 4th track? Is it this one? The one that finishes second is this one, which is the solid sphere. So if you look at the moments of inertia, I think you find that the solid sphere is the one that has the least moment of inertia. See, 2/5. So 2/5 is the lowest of these 4 numbers. So because the solid sphere has less moment of inertia than these other rotating objects, it's going to finish second. Anyway, I just wanted to go through that example with you as a sort of illustration of what we talked about last time. It won't make much difference what I change the mass to, but I'm keeping all the masses the same. See, I can make the radius bigger. Should we make them bigger? See if you see the objects are getting bigger. It's not going to make any difference to who wins the race, as long as they're all the same size. Same radius. The radius doesn't apply to the ice cube. The radius only applies to the other 4. Make it smaller. Anyway, but of course it would change if I changed their relative masses. I've got all the masses set the same. Anyway, I think that's enough on that particular question. That might help with moments of inertia. Okay, so let's talk about anything to do with either that or anything else, because I want to cover as many topics as we can. Yes?
Can you do number 5 on chapter 10, part 1?
Chapter 10, part 1. Okay, let's see. You said question 5, did you say? Is that constant, is that the one in the kitchen? The one that says some motion in the kitchen? No? Well, which one are you talking about? That's number 5.
That's the one.
In the kitchen? Okay, so first question is here, it says, what's the angular acceleration? So, we've got an object that's rotating. It says it rotates 20 times in 5 seconds. So if something rotates 20, so imagine you have a ceiling fan, I think this is a salad spinner, isn't it? Something that's rotating. If it rotates 20 times in 5 seconds, then it stops. Oh, I see. I guess that's not relevant to finding the acceleration, is it? It says, what's the angular acceleration as it slows down? The salad spinner rotates 6 more times before coming to rest. So that's really the part that I want for part A. So, what do you think we should do for that? We're going to use one of our equations, so I don't want to put them all up again. Can you look at which equation you think is relevant? So what's delta theta? Delta theta may be delta t, omega naught, omega alpha. Let's see which of these we've got. It says the salad spinner rotates 6 times before coming to rest. So what's delta theta if something turns 6 times? So I'm going to call it 6 revolutions. And how many radians in a revolution?
2 pi.
There are 2 pi radians in a revolution. So can we call that 12 pi radians? Okay, so if something turns 6 times, that's 12 pi radians. Delta theta. What else do we know? We're trying to find alpha, right? The question says find alpha. So we're trying to find alpha. So what else do we know? It says it comes to rest, doesn't it?
You know delta time?
Do we know the time?
It says 5 seconds.
No, but that's before it starts to slow down. It says it rotates 20 times in 5 seconds, then stops spinning. So I don't think we need the 5 seconds for the delta time. However, we do need to find omega.
You can find omega naught by converting to 20 times. in 5
Yeah,
seconds.
so I think we probably would use that to find the omega naught. So omega naught, the initial angular velocity, well, we know it turns 20 times in 5 seconds. So how many times does it turn in 1 second? 4. So that's 4 revolutions per second. So this is before he turns it off. I'd like to have it in radians per second. So how do I get radians per second? So how many radians are there in a revolution? 2 pi. We use this a lot, don't we? 2 pi radians per revolution. So what is that? 8 pi radians per second. When it comes to a stop, what's the final angular velocity when it stops? 0, right. I don't think we know delta t though. I don't think we've been told how long it takes to stop. So which equation do you think we should use for alpha?
Omega squared equals omega naught.
So should we use the one that's omega, I'll write it over here. Omega squared equals omega naught squared plus 2 alpha delta theta. So I'm using that as the analogy from the linear. So you have to be able to go from that linear analogy. So we have to go from the x, v, and a to theta, what is this, omega and alpha. So you need to be able to do those conversions that we've talked about between linear and rotational quantities. Okay, so we get this equation that we know is analogous to the equation we had with linear quantities. So what's alpha then? So alpha will be omega squared minus omega naught squared over 2 delta theta. Right, so I'm subtracting omega naught squared from both sides, divided by 2 delta theta. So let's put the numbers in then. What do we get?
0.
We get 0 squared minus
8 pi.
8 pi,
Squared.
that's radians per second squared, over 2 times
12 pi.
12 pi,
Radian.
so 2 times 12 pi radians. So that's giving me radians per second is my angular velocity, radians is my angular displacement. I'm trying to do everything in radians per second or radians per second squared. And also I'm looking at the answer, they want the answer in radians per second squared. So what's that going to be? Let's do that calculation. That's negative 64 pi squared over 24 pi. Should be radians per second squared. So negative, that's 64 pi squared over 24 pi. So what's that answer? I can cancel a pi. So what's negative 64 pi over 24? Will it let me put pi in? Maybe it'll let me put in the answer. Also the negative, do we need the negative, do you think? Let's try that. Let's see if it takes the negative. Negative. I think we should have a negative. And it may not want it. So can you just give me a calculation for 64 pi over 24? 8.37. I wonder whether it wants the negative. Yeah. Okay. So it says, well, the magnitude. You see how it has the word magnitude? So it doesn't want the negative. So remember, if it says magnitude, magnitude means take out the negative, because magnitude implies the absolute value, so it doesn't want the negative. Is that including the pi? 24 into 64 is about 3. That should sound like it's about right. Okay. Alright, so 8.38. So it wanted it without the negative. Okay, did you want to go over part B as well? Okay, how long does it take to spin down? Okay, so now it wants delta t. How long does it take to come to rest? So how do you think we're going to find delta t? So which equation should we use for delta t?
Omega equals
Omega
omega
naught
naught
plus
plus alpha.
My guess is we could probably use different ones. But which do you think would be the easiest one? I'll put it.
2 equals omega naught plus AT.
So omega equals omega naught plus, I'll call it alpha t. Okay, so I think that one should work for delta t, shouldn't it? So let's just work that one out quickly. So we get t equals omega minus omega naught over alpha. So that would be 0 minus 8 pi radians per second over alpha we just found. Should I use the 8 point, was it 8.38? 8.37? They wanted me to round it to 8.38. I would probably use more significant figures. So what's 8 pi divided by 8? And of course, that actually should be negative. That alpha should be negative. It didn't want it in the answer to part A because I want to get a positive answer for my time. You know, time is always positive. So I've got a negative divided by negative. So what do we get? 8 pi over 8.38. That looks like about pi-ish. A bit less. It was about 3, is it?
3.
What is it? 3? 2 point what?
2.9.
2.98, is it? So you're saying 2.99?
2.99.